Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Kirk Gray.
Hey, Kirk. I warned you in the last episode. I got another question for you.
Oh,
now,
no.
This one is like a whole page. I'm not going to read the whole thing.
Okay.
But it was from Anton.
Okay.
And I know he's been a long-time listener. We've gotten a number of questions from him over the time, so we should give him a gold star or whatever is appropriate.
Yeah.
Thanks for staying engaged with us.
A frequent questioner. We like those.
I like those. And this one's interesting. He says, I recently joined a project, and I've been advocating to do HALT. And the likely, during the design verifications, reduce the likelihood of being surprised later in the program. I think that's a really solid rationale for doing HALT.
Yeah.
All right. And so, but they have been, over time of this program, they've been doing growth tests, and they have found some design risks in some areas that they're already addressing.
I'm sorry, what kind of test?
So growth testing. So I don't know what kind of product. Growth. So they take systems and run them through it and look at how often it fails and fix those, and then go run it again and go fix those. But it's usually growth testing.
It's a Dwayne reliability.
Yeah, it's that kind of stuff. But there's lots of methods for doing it. But it's usually at operating conditions, right? Think of it as a tank getting run around on a track, or a car on a test track.
All right.
Right? And they're saying, we found stuff. And so one of the design engineers was saying, what's the ROI of doing HALT at this stage? We're already found stuff and we're already working on it. Now, he goes on, and it sounds like it might be a medical product. He talks about patient or user safety must be addressed, no matter where you find it. And what Anton's concern is that we're not finding all of those types of failure modes that could be harmful to the patient or the user. And that using it just at normal conditions isn't giving us enough stress to figure out what else could be failing. And so he's saying that the return on investment is that we will increase our chance of identifying serious failures or serious faults before we end up locking down the design and it gets way too expensive. And then he goes on that we're getting the typical pushback. He's really mentioning two types of pushback. One, we're already finding stuff and fixing them. And second one is we're going way beyond operating conditions. Why would that be relevant? And so he's getting the two classic, I think, pushbacks from his team.
Yeah.
And so then he wraps up, he goes, from his perspective, from Anton's perspective, in each of these cases, HALT still provides value. It helps us understand the design robustness, assess safety margins, make informed decisions about where to focus future improvements, and it can also serve as a confidence-building tool, especially when transitioning to design verification, because then you could use it to confirm what you already know about, and that you fixed it, versus discovering it later in the program.
Right. And usually you've gone well beyond the design validation test. When you do HALT, you should know that it's not going to be an issue. It's going to be a non-event because you've done it several times. But this kind of question sounds like one of my clients, basically the product it might be, who knows, anyway, that the product had been in the field. Labs were testing parts mechanically continuously and had been. They still had some issues in the field, which they knew about, and I had been informed of and talked to. And a lot of them were the fact that in development, this is why it's so difficult to do after the fact and after the product's been produced, is in development and using HALT, you're going to use it on the subsystems first, power supplies separately. If you can take a electronic card cage out and put it in a chamber separately next to the mechanics, But things like pneumatic tubes and polyflow tubes with liquid in them are going to be severely restricting in environmental in thermal tests. Okay,
Well,
because of the,
yeah,
I mean,
tend
right,
to
they're going to
melt.
be a very low limit on how quickly they become stiff
Well,
and can't be closed or open, or valves can't be closed or open
no, no,
because,
no, no, no. But
well,
if your main point of let's say I got to look at a one of these soda dispenser systems where it gases up liquid with a bunch of CO carbon dioxide, I think, or I don't know what it makes bubbles, and it's under pressure and all these
oh
kind of
yeah,
things.
it's a carbonation machine.
Carbonation process, yeah.
Yeah.
And
Okay.
their concern was, how do we evaluate our tubing systems and pressures? Well, use the HALT principle, go really low and go really high and take different temperatures in and around that and stuff, and then
Right.
have a mop nearby because when they break, you're going to have a mess. And they kind of frowned at me a little bit, but they said, yeah, we got to do that. We got to know where the limits are of these things. And one of their pumps was a roller that squeezed the tube.
Right.
And they were worried, how long will that last? I said, well, a quick way to find out is change your pressures and change your temperatures and see if there's always going to be the fatigue damage over time. But what else could go wrong?
Right.
Are you going to blow out a valve over here when this is constrained and you're at a particular pressure? You can do that today in the lab. Just go do it.
Yeah.
So they were got talked into it to see if they could make that happen.
Well, I'm always suspicious when there's a change in material properties because of that. I mean,
Yeah.
if you, like we talked about in a previous podcast, if you change you reach a temperature of reflow for solder, you've really that's an
Yeah.
irrelevant failure.
That's
And
right. And same with
if you
polymers.
crack a tube, a
Because it was
polymer,
frozen and
yeah,
it's a different material now, different
right.
material properties,
It's right, and you're changing,
then
or
it doesn't count. Yeah.
if you're cycling a valve and the sealing surface uh, climbs in temperature well beyond anything, it's going to change the property of that of the sealing surface of the
Yeah.
polymer probably, and you're not going to get a linear response in time so you've got to be very cautious about those kinds of things.
Oh yeah. And that's the same
So that's
with
one
it's
you
the same
can't
with
do.
any test. You got to think it through. There's not
Right.
a fixed system of it.
And you got to do it before the products early in the stages where you can separately
Look at the
test
various
the
subsystems and stuff.
ones because mechanics and circuit boards.
You're exactly right. It's the process of designing the halt, and we've talked about this lots of times, is that,
Right.
and earlier and often, you mentioned, go subsystems so you can isolate the stresses that are germane to, say, the power supply
Hmm.
and germane to the polymer systems and germane to the motherboard or whatever circuitry you got. That's part of it. But let's get back to Anton's questions. He had pushback from, we already are working on stuff. Don't, and I read the subtext of that as going, we don't need more things to work on.
Right. If they've got good field data, they probably don't. They need to fix those. If they
Oh, no,
don't,
no.
if
This
they,
sounds like it's not a fielded product yet. It's in design
oh,
and they haven't
okay.
gone to validation yet.
Okay.
And so
All
he's
right.
making the argument, let's do it now because if it shows up later, we have even less time and it costs us way more to fix it. So let's find out what could go wrong, triage that with all the other things we're working on, and make sure we're working on what's most important to get done and save time and money in the verification process, which we'll either find it there or the customers will find it. In both cases, it's way more expensive. And I think the pushback
Right.
is, but we're already finding stuff and fixing them. And I like, okay, what if there's 10 more things that are critical that you haven't started yet and you just are unaware of them? And it's a what if. There's two outcomes I can see from HALT. There's three. One is we find a bunch of stuff you really should fix. Serious safety issues you need to fix now. And
Yeah.
skip all those little fancy stuff that you are fun projects for you to work on. And they don't like hearing that. Two, we find one or two that we already knew about, and that's it. And like, okay, you're already on the right track, but now you know. that there aren't other things out there out to the limits of what we
Okay.
got.
They're finding things, and okay, the question is, when are they finding those things? Are they finding them right at the end of building it and then turn it on and it finds it,
This is in
or is
design.
there?
It's before
Okay,
design
it's a new design.
verification. It's early in the program,
Okay,
earlier in the program. So they're
okay,
probably dealing with prototypes,
okay. So
functional
the
prototypes.
right, and you got to be careful with that because there's a lot of spaghetti on the board. It might be things like that.
I think it's, yeah, probably
So
further along than
there's
that.
a
But
time that you don't start halt. You wait for a while until the product's somewhat not mature, but the design is considered mature, and the first prototypes have been developed, and you've got several, maybe
yeah,
100
instead of
samples.
molded parts, you're using, cut parts. You're not using
Right,
your molding tooling to do it, but you're using
but right,
say, an additive process to make the skins on the system. So if a
right,
failure of
okay,
that material is not as relevant as the failures of your molded components, but you don't have them yet. But you can
okay.
still go after all the internals of what's going on in your
Right,
system.
but look at what you're finding already, or what somebody's finding, or what the
Hmm.
issues are. If it's a bunch, then yeah, look back and see what those are, why those are failing, probably in time. If they're not dead on arrival, dead when you design it, and all of them are, then you got, your
You've got
design
other
doesn't
problems.
work. Yeah, you got other problems. But if you got a few that are working and a few that don't, then you've got a differentiation that you can study, and you can use HALT to stimulate that. Also, stress to stimulate the speed and accelerate that. So if it is a failure in time that you're seeing for your prototypes or whatever that are working at
Hmm.
some point zero and then fail over time, if you were to show through accelerated stress testing, either, depending on the mechanism that you've
Yeah,
identified,
you can move that faster.
because you had a failure. So potentially what the stress is. This is how also you can show the value of accelerating it by, say, it took a week to find this thing. You were running it on a
Right.
bench, and then you took it into a chamber, and
You can do it in
in an
2 hours.
hour,
Yeah.
it showed itself. You say, "Look, guys, I discovered the same weakness at an hour in this chamber, and we have the potential to find many more in the future. But first of all, any failure." Any failure you've got already from the prototype line is kind of going to be manifest in high volume production, even if it's a low rate, then it becomes a
And
significant
it becomes a
number.
problem.
It
Yeah.
even depends on so the first thing is he's got to, you know, I really, the value of it when you can't modify or have built test fixtures to kind of do uh, separate the mechanics from, if you can, and it's not always possible. Like in disk drive, when spinning disk drives, you can't really, take the disk out. You can't even separate the circuit board very far because of signal integrity and
Timing
signal
and stuff. Yep.
timings. Yeah, so for the kind, so you've got to. It's like again, I
You're showing
focus.
your age now, Kirk.
Well, no,
Nobody's using
halt
these
is very,
spinning discs.
yeah, I
Nobody's
know.
using spinning
Nobody's doing
drives
right.
anymore.
I know. Well, I think some of them are still there.
Yeah, they're out there. They're out
Solid
there.
state discs are still more expensive,
Yeah, yeah.
but definitely more potential reliability. So the point is that eh, there is some possible value after the product's probably been designed and
If you're
you've
not going
got
to change anything,
prototypes.
no test is valuable for you.
Right.
You know,
But if you bought a 10,000 parts already, you've got all your, supplies, your circuit boards are all cut and, printed, whatever. Yeah, you're going to have a hard time justifying this unless you can make
I'm
a
going to flip.
significant monetary amount. You got to make
Right,
it a
right, right.
business
No, you got
case.
to find a business case either way. But I'm thinking of I think the next point is that you need to stop talking to the engineer. He really doesn't want another to-do list to go fix something else that his
Right,
initial design didn't consider or deal
right,
with. And that's part of development. That's why we call it that. And
right.
then should talk to that program manager saying, do you want to know now or you want to know later? Here's the cost difference of what it takes to fix something later. And if it's a time to market product, you could say, how much does it cost to spend a week fixing something we could find out today versus a week before launch. And they go, all right, find it now. They want to reduce the risk of delays. They
Right.
want to reduce the risk of overruns and
I
cost
know.
overruns, all this stuff. Talk to the people calling the shots with that business case. The engineer brings up good points. And at some point, it's a gray scale. Is, yeah, we already found everything we need to know. We got a long list of field data and history, and we know what to work on. Well, HALT doesn't have as much of a value in that case. Now, if there's something new or something unique or a new innovation brought into it, focus on that part of it. HALT's
Right.
really useful there.
Right.
Now, the
Right.
second question, let's see, now you got me so wrapped around the axle here, Kirk, that I don't even remember it.
I'm glad, Fred. I
Oh,
want to get you
it was the way beyond
spec.
operating
Right.
specs. Yeah.
Right. And that's the only way you're going to get acceleration.
Okay, that is easy. Okay.
You don't accelerate by simulating the end use environment. That's equal time,
Yeah.
unless, I mean, you can do things like
If
you
you
can
got 10
do,
years,
like,
go do it.
I mean, you can increase the frequency of something like power cycling or whatever.
Yeah,
But
even hinges, some people,
hinges, right? You
just move
open
them
them,
more
close
often.
them, right,
Yeah.
right, right.
Or give them to our kids and they'll drop them for you for free.
But also, management's going to say, how do you know that you're going to find this? And there are mechanisms, and maybe this is going to be shocking to you, but there are mechanisms that are very difficult to find in HALT. For instance, battery problems,
Yeah. Yeah.
battery issues that
Yeah, because you're
very
not charging
significant.
and discharging it
You're not discharging and charging it. There's a chemical reaction in there that just takes time and it takes cycles. And
yeah.
it's really hard there's no stress that can really accelerate some of the breakdowns of that.
Well, crack initiation in materials and its propagation,
Oh, absolutely.
it takes time.
Solder, yeah.
Solder and metals and
Right. It
hinging.
covers, I see it covering about 80% of the 80 to 90% of the relevant field problems. But there's some
Some
that
things
like
that just won't
ec-
catch, and that's good engineering to
right, like
consider those. But
aluminum electrical caps, we talk about that at
yeah,
the time. Well, it was one stress, it was elevated temperature that could accelerate that. If you did, and I did this because it was a problem back then
hmm
in computers, that I did thermal cycling on these, not just elevated, but step stress, and it was only a few minutes. So that wasn't long enough
yeah,
for this.
because
So,
it's a chemical
but if I
process, a
did it in an
diffusion process.
hour,
Yeah.
right, if I did it for an hour, which I did later, prove that in an hour at 95 C, if I suppressed the CPU again, because it would shut down at 65 C, if I suppress that in an hour, I could see these aluminum electrolytics bulge and
hmm
in fact vent. And
Wow.
yeah,
Hope you
so
had safety glasses on.
what?
Hope you had safety glasses on.
Fortunately, that's what's why a chamber is really
Oh,
good.
okay, really handy there. Yeah.
I'm not
Now you got
standing
to
over.
wipe all this corrosive stuff off the chamber.
I'm not standing over it like the eggs in Alien,
Yeah,
where
there you
he
go.
watches, he looks into the egg. That's the same.
Not a
That's
good
what
idea.
that's what the vents look like when they split open at the
Yeah, yeah.
top.
But anyway,
But
the idea is that the people will push back one way or the other. And these are two of the most
well,
common
sure,
things we hear about. And then one, the business
absolutely,
case really helps and to say, but it reminds me of years ago, Mike Silverman, when he was running that HALT lab in
right.
Santa Clara, he
Uh-huh.
said, we've done hundreds and hundreds of these things, and these are the things we typically find. And when you
Right.
look at the list, it was 9 out of 10 of them were not long life things. So that weren't, solder joint fatigue. They weren't all the things that you often talk about. Why are we studying that stuff? That's way out there in the distance.
Right.
You
And
know,
you know what
uh,
I say to
if
that?
no, 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 I know, but he was saying, if you don't mount your electrolytic cans on the board properly, you got this long tail of a lead there,
Right.
and there's any vibration at all, that
Right.
little piece of metal is going to fatigue and break pretty quickly. And
Right.
a little bit of vibration in a halt finds those like that, right? If you've
Right.
got vias that are not filled properly, they're going to crack with a few
Right.
cycles because it's very thin metal. And
Get
if
back
it,
to the capacitor. It doesn't take much to bring that flush to the board. Sometimes that's all
But
it
that's the
is.
point. But
That's the
it's if you're
point.
not, but you're not, the design guy is saying,
Okay.
I need a certain value of capacitor at this point on the board.
Yeah.
He's not, he's assuming it's perfect. And then we get our prototypes back, or even our first run back from the production line, and we run a halt on it. And like these things are falling apart.
Mm-hmm. Mm-hmm.
That is not found in any other accelerated life testing or physics of failure modeling or any other stuff. That's a problem with the manufacturing,
No,
right?
or component adjacency, where components suddenly touch each other because
Yeah,
they're
and cause
loose
problems in wear. I had one where a wire from the
or
battery
short.
compartment went it was a came out of the battery compartment, did a right angle right above the board,
Mm-hmm.
and it was resting right across the, oh, I forget the name of it. The coating wasn't a conformal coating. It was just the regular goop they put on top.
Solder mask
Solder
or
mask. Yeah, yeah, that's it. I've drawn a complete blank. And there was the opposite polarity lead trace was right under it. And so
mm-hmm.
with just, it was like 10 minutes in the chamber with a little bit of
Right.
vibration, dead short. Drain the
Right.
batteries back completely. This, you open the chamber and it's the smell of burning phenolics, you know.
Right. Right.
And it's like,
So
hey, that's, we would have never found that with engineering and physics of failures and everything else. And, you know, but
no,
10
and you're not
minutes in
going to
the alt
find
chamber,
uh,
beautiful.
you're not going to find like proximity problems where a heat sink is, slightly bent one way and
And
is
wears through
close,
something else. Yeah.
and there's another component right near it that the lead it touches if it's.
Yeah.
So yes, those are I think they're getting better uh, CAD simulation, stimulation tools, and there's some of this, but I haven't, the physics of failure, multi-physics modules and things like that. I haven't been familiar with, so I don't know
Yeah.
how
They're
good they're
getting better,
getting.
but it's again, it's for those types of failure mechanisms like time domain problems or crack initiation and fatigue
Right.
problems or all those stuff. But it's usually assuming the board is made well.
That's exactly it, Fred. That,
Yeah.
that assuming that all the components are manufactured to their specifications,
Or better.
assuming the epoxy on the encapsulant is exactly the right TCE, thermal
Yeah.
coefficient expansion, all that's making assumptions that those don't change throughout the product's manufacturing life cycle. And you and I know that that is absolutely not the case.
Oh, but
And
we didn't tell you
especially
because
if
it was
you,
just a small change.
yeah, we've just changed that component to another vendor, and he
The
had the
same
same
fit, form, and function.
specifications. Yeah,
Same fit, form,
he
yeah.
came in the same
It doesn't
specifications.
work at all.
What do you mean, counterfeit supplier?
Yeah, 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 they're
It
cheaper
looked,
for a
it had the
reason.
label on it. This is exactly the same.
Yeah, it's cheaper for a reason. But
Yeah,
anyway, Anton asked a couple of good questions, and when I first responded to him, I was like, "Yeah, those are here's a couple of ideas to it." So I'm going to point him to the episode and see where we can go with that. But
well,
it's not uncommon to get pushback, and sometimes it takes. Our last episode, Kirk, I challenge you with, well, have you ever been in a place where they just get it? And it works great. And he said, yeah, but there's still pushback. There's still the new guy comes in, or
I
somebody's like,
know,
I'm not sure
I
about
know.
this, or it's,
It's a real big challenge, and of course, I want to plug my book and say, look, I wrote a chapter about this particular
he's
problem of dealing with management. And in my book,
pushback.
Next Generation Halt and Hass Robust Design of Electronic Systems, is still, and it'll be May, it's 10 years that it's been published.
Well,
And
when's the
so it's
second
still,
edition coming out?
Fred, that first was, and I can't think that I'd add anything to it in those 10 years.
Yeah,
I would add more about the timing and the signal integrity issues that I
yeah,
think
the recent
thermal
paper you did
stress.
out. Yeah.
Yeah, yeah. I would put more emphasis on that with the high speed and the low, we're getting very low voltages,
Hmm.
much higher speeds. And now there was even an article about how signal integrity is becoming more of an issue in reliability of data systems and
Yep.
large data systems. But I just want to say that that is one of the chapters that I, wanted to emphasize how difficult and how long term the the realization of reliability is. You don't realize it unless it's a short term, unless it's always the front end of the bathtub curve that it's going to
We pay
cost
attention
you.
to. Yeah.
Yeah. And so, whether that you get to the wear out, you're probably going to change jobs or do something else, and nobody's going to care because it's
Way
most
beyond where
consumer
we.
products are technologically obsolete before they get to the wear out.
Yeah,
You've
or
got
it lasts
VHS.
long enough that, yeah, that was fine. It did what I
Oh,
needed.
yeah.
The ones
Well,
I hate, and this is a whole nother episode, is I have an iPad and it's about 6, 7 years old. It's not as
yeah,
old as your phone,
right,
and but it still works. And eventually, Apple's going to say, "Well, we're not
nope,
going to support that anymore,
that's right.
and you're on your own." And if it's at some point, the various applications and stuff will get faded out. And I was like, man, it's a thousand
But it
dollars of it.
operates.
It's
It's
thousand
got
dollars
life.
equipment. It's got
Yeah,
life. It's doing
got
fine.
plenty of life.
I can play Sudoku to my heart's content. But
Right,
what happened to, checking the weather or a quick check to a website or all that stuff? It
right.
should just last for another 30, 40 years.
Well, I don't know if you keep your old phones around. I do.
No, I
I
don't.
don't necessarily trade them in because, I like them as backup, but they work fine as a Wi-Fi, connecting to the Wi-Fi in the
Yep,
house. I can do
yep.
all the things I did without the cell service. I just got a new iPhone.
Well, you did. You moved up from 6 to 16 or something like that?
No, to 15, which
Oh,
Apple
okay.
doesn't make. So I had to go to get a used one. I had to and unfortunately the battery was 89% of its capacity, of its original
Well,
capacity.
yeah.
So I did, and I did have to reload the software one time because the camera didn't work. So it makes me question, do I trust this thing in the future? Well, that's kind of why I keep a backup phone.
All right.
Except, anyway,
Our,
we can talk
we'll
just
go into a whole
forever.
nother episode.
Yeah.
Our purchasing patterns for electronics,
Yeah.
given our backgrounds, that might be interesting.
Yeah.
But if you're listening to this and you're like, what in the world are they talking about? But Anton hopefully got a couple of good pointers here and feedback, and I know I need to add an update to my response to an initial one. But if you've got a question or you'd like to hear us chat about whatever it is related to reliability-ish type stuff, let us know. Head over to accendoreliability.com/go/SOR. A couple of ways to get in touch with us there. Kirk and I and the other hosts of the show are all available through LinkedIn and our about pages on the site. So plenty of ways for you to get in touch with us. And I mentioned this in the last number of episodes that I've got a handful of when we're working through a small stack of comments and questions and suggestions and stuff like that. And so, Kirk, I saved the two on HALT just for you, and so we had a good time with that.
Well, yeah.
And next time we'll talk about, parts count prediction. I know that's your favorite topic. But if anybody
Well,
got a question for us, just send it on over. I'll add it to the queue and we'll get you an answer back and we'll chat about it and help other people too. Because if you've got the question, probably somebody else does too.
yeah, and that's what I'd like to say to Anton, right? Is his name?
Yep, Anton.
That wrote it. Said that welcome to the fight, because I guarantee in every organization that you try and introduce these new concepts of testing to limits, you're going to get pushback. You're going to get pushback from somebody somewhere in that organization because they think you're going to bring up irrelevant failures and irrelevant mechanisms that really will appear in the field, and it's just a constant. That's why we've got to speak out against and promote it, because
Yeah.
nobody else shares any data about real failures in the field. They just rarely do. So
But that's why we're here. So we'll
that's
help
why
you.
we're here, and
We'll help you best we can.
that's right. Okay, Fred, let's do it again sometime.
All right, real soon, Kirk. We'll talk to you later.
Okay, bye.
There's.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.